All right, guys. So number one, what is happening here? Flips over the x-axis, and then which way does it go? Left 2. So there.
No, like the most pain I've ever been in. It's okay. No, I couldn't.
Yes?
No.
How'd we do?
Yes. Why do we do it this way?
Okay, so let's think about the parent graph is here, right? Okay, so if you flip that over the x-axis, you guys flipped over the y-axis, I think. Think about just turning it upside down and then shifting it to the left too. Because if you flip it this way, that's what it would be. So flip it and then shift it? Yes, I think. Yes. All right, guys, are we okay with number 1? Could you do domain and range if I asked you? Yeah? What's the domain? Just tell me.
-2 to infinity.
-2 to infinity. The range. -infinity to 0. Okay. All right, guys. Number 2, we also have a flip and a shift, but this time what axis are we flipping over? Flipping over the y, and then where are we going? Down. And then somewhere way up here, and somewhere way down here. My graph is clearly not pretty, but... Oh, I did cubed, not cubed root. Oh, wait! Woo! Okay. Okay, so like way over here somewhere, and way over here somewhere. It's just panicked, didn't you? Everyone's like, I'm so sorry, I am human. This does happen. No, I'm not allowed to be human. Not me. Oh dear, what am I then, Bobby?
My feelings are
A Nebraska? Nebraskans are not humans. All right, guys. Are we okay with that? I'm starting to think you guys don't think much. Oh, okay. Super. All right, guys. Here is your homework. Were there any you guys had issues with on your homework?
Yes, no.
15. Yes, 15 was a common request. Yeah, hold on. Let's do 15 first. All right, guys. When you look at 15, did you recognize right away that, oh yeah, that's the one with the asymptotes? Okay. And there's no shifting, so those are still going to be right there, right? Okay. Then it's a stretch by 6. That's sort of hard to think about with this kind of graph. So what you need to do, just think about plugging in a couple of values. So if I let x equal 1, what does y equal? 6. Okay, that's that point right there. What if x is 2? What's y? 3. What if x is 3? 2. And you don't have to do all of these, but what if x is 6? 1. Okay, do you guys see the shape? And then, do you understand how you'd have those on the other side, too?
Oh, yeah.
No. All right. Are you okay with the domain and range of that one? Yes? Okay. So when in doubt, you can always plug in points if you're not sure. It's a good way to check to make sure you graph the right thing, too. Okay. Okay, what else? Somebody said domain on 5, or?
I did.
Yeah? Okay. Okay, so remember it's all real numbers and we shouldn't write it like us. This is somebody else's key. Should write it that way, okay? You can do the funky Z, like if you're technically doing it right, it would be the whole brackety y such that y is an element of the real, y is an element of Z, the integers, and then you'd be done with it there. Yes, unless I put like a coefficient on there and it jumps, and so then it's like all even integers or something like that. But we'll talk about that if we get there. For most of what you're going to do, yes, integers. Okay? How do you do a stretch on those? So let's just go through. So this is just your parent graph, right? We'll just do a couple. Okay? If you put a coefficient in front, what that means is you're now 0 to 1, okay? But instead of coming up 1, you're going to come up 2. So it's like you jump. Yeah, you'd have to say like even integers, that sort of thing, okay? Does that make sense? Okay. You literally write the words even integers, and that's all you have to do. Yeah. That's it. With these, if we looked, and I don't think I ever give you any of these, but just so you're aware of like the horizontal stuff, like if the 2 ends up in there, if it's outside, it changes like the height of your steps. When it's inside, it changes the length of your step, and it does the opposite of what you think it should do. So a 2, you would think doubles it. It doesn't. It cuts it in half. So it goes from like 0 to a half, and then so you've got these like itty bitty little tiny steps going on. Okay. If you had a half in there, that is what would double it. So you'd be going all the way to 2. Okay. Again, we don't do tons with these, but just so you're aware, that's what happens when you have that coefficient inside your parentheses or your brackets. Okay? We've digressed. Anything else from the homework?
Would you use this type of graph in like a real life situation?
So a lot of times things with money get rounded to the nearest mile, nearest minute, nearest something like that, where you're having to pay for something. Nearest hour, like cell phone minutes, car rental, if you're renting by the hour, that sort of thing. Like it always rounds to the next hour. You can't rent a car for 2 hours and 17 minutes, you know what I mean?
Yeah.
So it's that sort of thing.
So you said we're not against the ones like 2x.
Don't stress about those yet.
Okay.
I don't think, I don't want to say for sure, because I don't think they're on any quiz or test.
Will you like notes on that?
We'll do more of that in class if it's going to show up on something. All right, Felipe? 7? You're skipping over -2 because that's where the asymptote is. So negative infinity to -2 and then -2 to infinity for the range. So wherever this ends up being, you know, that's what you have to jump over, like this one. You have to jump over. I'll put the video up on Blackboard today, okay? All right. Anything else, guys? Were you guys okay with those ones at the end?
Yeah, 21.
21, sure. So guys, the first thing I would do if I give you a graph like this, I would make a table of values of these points. Okay? So that's what I've done here. When there's a 2 out in front, 2f of x, that means you're taking the y values times 2. So just look at your table and go, okay, so x is going to still be -4, but y is now going to be 4. Okay, x is -2, 2 times 0, that's still 0. At that point. 1, 0, 0, 3, 2 times 4, you're all the way up there at 8. Okay? Does that make sense? So just go through the points and multiply the y values. Yes. Okay. Anything else? Okay. We are going to start notes. We're going back to 6-1 today. You need paper for these, guys.
What? No, that's oh no, the one who's in
All right, guys, jot down the title, 6-1 functions. A lot of what we do today you will have seen before in Algebra 2, okay? Yeah, just without your calculator. All right, we are going to do some function evaluation. So guys, go ahead and jot down the f of x and the g of x, and then this is like your examples 1, 2, 4. Okay. No graphing, no calculator, no. Just write it down and then I'll walk you through. I'm trying to take attendance, but Sis does not like me today. So. You're just writing down what's on the screen, and that's it right now. Your notes? Yeah, notes are not in your packet. You just have to do them on paper today. All right, guys, we ready? Dear Franz, you okay? Yeah, okay. All right, guys. So f of -1. The f tells you which function to use, so we're picking the f of x function. And then what do I do with the -1? Yes. So this equals 2 times -1 squared plus 4 times -1 minus 3. And yes, without a calculator, you can do this. So what's -1 squared? Not -1. 1 times 2. Okay, and then, do you guys see that's minus 4 minus 3? So what do we get? -5. Okay. So you guys remember your order of operations. That's it. You're just plugging it in, seeing what you get, okay? You've done this before, right? Yes, okay. So g of 2. So I picked the g function, and then I just plug it in. 5 minus 4 times 2. 3 times 2, that's 7. So what do I end up with in my numerator? Negative 3 over? What? 13? Yeah. I just need to hear what you said. And we can't reduce that, so you're done. Easy so far? Okay. All right, so the f of a plus 1. A little more work to do on this one, because it's 2 times a plus 1 squared plus 4 times a plus 1 minus 3. So, the biggest mistake I see on this is either you distribute the 2 before squaring, or you square incorrectly. What does it mean to do a plus 1 squared? Yeah, a plus 1 times a plus 1, and then you get FOIL, multiply it all out, okay? So really, we have 2 times a plus 1 times a plus 1. You can go ahead and distribute here. This would be 4a plus 4 and minus 3. What is a plus 1 times a plus 1? Good. Okay, distribute again. And guys, if you combined a couple of these steps in your work, that's completely fine. I'm just showing you everything to make sure we don't miss a step. All right, so 2a squared, nothing to combine with that. What about my 4a's? What do I end up with? 8a, and then 2 plus 4 minus 3? Plus 3, and there you go. Okay. A little more work, but is it really bad?
What if there was plus 2 at the end to be simplified?
You could factor, but you don't have to at that point. Because usually simplify means not having parentheses anymore, and so factoring creates those parentheses. All right, we okay with 3 then? And guys, if I go too quickly through anything, just tell me. Like, again, I'm assuming you remember some of this from Algebra 2, so stop me if I am wrong, okay? So G of 3a. So for this one, we'd have 5 minus 4 times 3a over 3 times 3a plus 7. So what do we end up with in the numerator, guys? 5 minus 12a, good. Over, what do we have down here? Close, 9a plus 7. That's all. What do you think? Can I reduce that? You cannot. Some people will look at it and see the 9a and the 12a and think you can do something with that. But because there's addition and subtraction involved, you cannot. Okay? So that's it. Good so far? Yeah. Do you like seeing stuff you've seen before? Okay. And guys, so I don't forget at the end, you do have a quiz next class on 6.1 and 6.2, okay? It'll be at the end of class, and we'll do a bunch of practice before it. Just a heads up. Anybody need more time on this one, or are we okay? Good? Okay. All right. Let's not write all of this down because I think you guys know this. If you don't know this, tell me. Do you know what domain and range are? What is domain? Okay, what is range? Okay, so let's just do these together out loud. What is the domain of this first set of points? Okay, do I list the 6 twice? No, okay. Squiggly bracket, 6 and 10. Okay. What's the range? Okay. And I don't care if you put it in order or not. You can tell me just how it's listed, 3, 5, 2. Some people like to go in order and say 2, 3, 5. Some of you go in reverse order. It's okay. I do not care. All right. Now, is it a function or not?
Is it past the vertical line test?
Yeah, would it pass the vertical line test?
Yes.
Okay, if I plotted these points, so 6, 3, 1, 2, 3, 4, 5, 6, 3, 10, 5, and 6, 2. Do you see an issue there?
Yes.
Yeah. These are the same.
Oh, so
Yeah, so if any x's repeat, it's not a factor. Yeah, which one is it? Y does not matter. You can have the same y 10 times and it doesn't matter. Okay. All right, so again, out loud here, tell me domain of this next one. Okay. What about the range? Okay. Function? Okay. Am I right? We kind of remember this? Okay. Anybody questions before we keep going? You will definitely have questions on your quiz like that. That are just tell me, list the domain and range. I want to skip that. Let's just start here. It looks scary, but it's not. Ignore the title here. We are just going to do some domains. So right, state the domain. Those are your directions. And then go ahead and copy down both of these questions. Thank you. All right, guys, so when we're looking at domain, when you're trying to do it algebraically, there are 2 things you need to look at. The 2 things that can sort of cause problems for you are if you have a fraction or if you have an even root, like square root, 4th root, something like that, okay? Those are the only 2 things you have to look for. If you don't have either of those things in your equation, then your domain is automatically all real numbers. Okay, but if you have either of those, then you have some work to do. The fraction ones are easier. What do you guys know about fractions? Yeah, problems when the bottom is 0. So what you need to look at, we don't really care about the numerator right now because the numerator doesn't have a square root in it. So we can just focus on that denominator. So this x squared minus 4, we want to make sure that that does not equal 0. Okay. How could I solve that? I've got 2 options. Did you say unfoil? Okay, so factor, is that the word? Okay, lots of people today have told me unfoil, so yes. Let's factor. So what does x squared minus 4 factor into? Good. So what do you think the two things that x cannot equal are? Okay, so plus or minus 2. So those are the values that don't work. Actually, writing your domain, you have to write it in the proper notation. So you've got two options. You can do the interval notation, which is negative infinity to negative 2, negative 2 to 2, 2 to infinity. Okay, you're jumping over the negative 2 and the 2. Let me move this up a little for you guys. Or you can do the set notation. You've got your nice squiggly bracket, x such that x is an element of the reals. X cannot equal positive or negative 2. Either of those works just fine for me. Okay? Yes.
Are you ever going to ask for a specific one?
I might. The good thing to be aware of both is multiple choice questions I could show you either way, and you'd have to be aware. Okay? Usually I'll just say state the domain. If I ask for a specific way, it would be interval. I won't ever ask you specifically for the set notation. Okay? Yeah. Not unless it was a multiple answers can be correct sort of question. Okay. All right, are we okay with that one? Okay. Let's look at the next one. So guys, again, we have a fraction. We don't need to really worry about the numerator. Something would cancel out. I don't know if you guys remember that creates a hole in your graph from last year. Is that vaguely familiar? No? Okay, well, it still matters for the domain. You still just need to look at your denominator. So this x squared minus 4x, that cannot equal 0. So what do I do with it? Take an x out. So what are the two things that x cannot equal? 0 and 4. Okay, so again, two ways to write it. What would I write for interval notation? Okay. 0 to 4, and then... Good. And you guys understand why it's parentheses on all the numbers there? We good with that? Yes.
So what happens if we have like an x to the fourth?
You would just have like if you ended up with 4 different things, is that what you're asking?
Yeah, like would you have to do the numerator also?
Nope. 4th root, yes. Not just to the 4th power. Okay. All right, and then if we did the set notation, x such that x is an element of the reals, but x cannot equal 0 or 4. Okay? Yes?
How come we didn't put 0 in the first example? And second,
This one?
yeah.
Okay, does 0 work here? 0 minus 4, is that 0? Like if you were solving this equation, so if you had,
Oh, like would it put 0 down?
like, I'm trying to figure out what would make that 0, because 0 work. The only things that work are 2 and negative 2, right? So those are the only things you have to worry about. 0 makes your numerator 0, but that doesn't matter for this. Okay. All right, ready for more? Okay, so again, ignore all of this. We're stating the domain again. So jot them down. What is it, 7 and 8? Give me a second to write both. All right, got them written down, guys? Okay. So do we have any fractions this time? No fractions. So number 7. Do you guys see how this is an even number right there? Okay. That means we got to be careful. Because what can we not take the square root or the 4th root of? Anything like that. Negative numbers, right? Can we take the square root of 0? Yes, you can. Yeah, I'm not trying to trick you. Just making sure, yes, you can take the square root of 0. So what you do is you take what's under your radical. So this 2x minus 1. And we say that needs to be greater than or equal to 0. Okay, because we want to make sure we can take the 4th root of something positive here. And then you just solve the inequality. So I would add 1 to both sides. Divide by 2. And that's your domain. X has to be greater than or equal to 1/2. So the way you can write it, hard bracket, 1/2 to infinity, which is definitely the quicker way this time, or x such that x is the limit of reals, x is greater than or equal to 1. Okay. We good on that one? Those I can definitely make trickier by what I've put under the radical, but the general idea is always you have to just set it greater than or equal to 0. Alright, so let's look at number 8. Do I have a fraction? No. Do I have an even radical? No, that's odd. So what's my domain? Yes, okay. Don't get lulled into thinking you have to do a whole bunch of work on every single problem. You guys will be in the routine of like finding what makes it 0, finding what makes it positive, and then you'll try to start doing a whole bunch of work on this, and you don't need to. Okay? What? Yes, exactly. It's like the new triangle thing.
Is there another symbol starting there?
You could write x such that, oops, x, not x is an element of the reals. If you just write that on your paper, I'm not going to give you full credit.
You're not.
Because it's not proper notation. So either of those works. The person who made the answer key a while ago definitely used the R's sometimes. Ignore them. They're not right. Okay.
What is the inequality for 7?
So think about your square root, even your graph of square root, like y equals square root of x. It looks like that, right? Wouldn't you tell me the domain is like x is greater than or equal to 0? Or 0 to infinity? Okay. So that is what you're starting with. I'm shifting the graph around, but we still want it to be based on that. Okay. All right, we okay so far? Nothing bad yet, right? Okay.
Yes.
I know, there's one thing that's tricky today, so. All right. This would be the part that's tricky, okay?
Do you know that? Each one is pronounced differently.
That's interesting, yeah. Yeah, you getting any of this? Yeah. Yes, I appreciate the insight there.
You're very welcome.
Thanks. All right, guys, I'll let you jot these down. Leave yourself a few lines in between the 9 and the 11. We've got a little bit of work to do with these. We will definitely do these together because these are different than the ones you've already done. I just want to wait for everybody to write it down. I always feel like it doesn't go well if I start explaining while you're still writing because you're just not listening to me yet. So. right, guys. So, no fractions here, right? But we do have even radicals, correct? Okay. What is different about these than what we did on the previous slide?
There's a square.
There's a square. Yeah, see how we've got these exponents here? That means you have to do more work, okay? So, you start the same way. Take what's under there, x squared minus 9, and say that that's greater than or equal to 0. We can factor it. So x minus 3, x plus 3 is greater than or equal to 0. It's not an equation though, so you can't just set like each little parenthesis greater than to 0. It doesn't work that way, okay? What you have to do is called a number line test. So we're going to make a little number line. I'm going to have two things on my number line because I have two factors. What do you think the two values are going to be on my number line? Yeah, negative 3 and 3. Put them in order. The negative 3 comes first. All right, we are going to test these different regions of the number line. So if you pick a value over here left of negative 3, what's a number over here? Negative 4. Where you plug this in is into the factored form. So what is negative 4 minus 3? I heard a mumble, but negative 7? Okay, so definitely a negative number, right? Okay. What if I plug it into the second parenthesis? What's negative 4 plus 3? Negative 1, so that's also negative. If I multiply the two together, what do I get? A positive number. So that little section is positive. Are you with me? Okay. We move on to the next section. So what would you pick in between negative 3 and 3? What's the easiest thing to pick in between there? 0? You can pick anything that's in between there, but 0 is the easiest. So what's 0 minus 3? Negative. 0 plus 3? Positive 3, right? And what's a negative times a positive? Negative. So that little section of our number line is negative.
This is like the final answer.
That's how you're going to write your final answer. You're going to turn this number line into your domain. Okay? All right, we have one more section to check. What do you want to pick bigger than 3? 4, okay. You don't have to. 4 works. 4 minus 3, what's that going to give me? Positive. 4 plus 3? Positive 7, okay. Positive times a positive? Positive. All right. Are you with me? We're almost to our answer, okay? If you remember the original inequality, we wanted this to be greater than or equal to 0. Well, it equals 0 at these 2 points. And then greater than, do you think that's the positive part of the number line or the negative part? Positive. So I want this section over here and this section over here. Okay. So to turn that into your answer for domain, start at the left, go to the right. So that's negative infinity to negative 3 with a hard bracket on it. Hard bracket 3 to infinity. We are clearly going to practice more of these, but questions on that one?
Why did the plus or minus 9?
We want to know where on this number line is it greater than or equal to 0, which is the positive number. So
Could you just simplify that to x minus 3?
you do whatever. I don't know what that means.
So that's
So you think if I have the square root,
I just like noticed that
no, I'm just asking you, so if I have the square root of 9 minus 4, do you think that's that?
yeah.
Okay, 3 minus 2 is 1. What is 9 minus 4?
Oh, okay, I see.
No, not this. Okay, so no, you can't do what you said at the beginning. Okay,
Makes sense.
it's always easier with numbers. Okay, questions on 9? Do you want to do one more together before I have you try one on your own? Yes, okay. All right, so let's start 10. Maybe we're going to do 4 together, I don't know. So x squared minus 3x minus 10. That has to be greater than or equal to 0. Okay, that's where you start every time. Then we have to factor it. What is that? Factoring never goes away, sorry. What does it factor into? Good. Okay, x plus 2 and x minus 5. All right, number line is next. What are the two numbers going to be on your number line? -2, +5. You okay with that? It's what actually makes the parentheses 0. Okay. All right, so what number are we going to start with for plugging in? -3, and where am I plugging that in? X into that factored one, right? Okay, so -3 plus 2, what do I get? A negative. And I don't really care what the number is, I just care if it's positive or negative, okay? -3 minus 5. Negative. But a negative times a negative is positive. Magic. All right. So you're picking your number line here. What's something over here? -3. Okay. You plug it into this factored part right here. These two factors. So what? X is becoming the -3, which is -1, which is a negative, and -3 minus 5, which is -8, which is a negative, and then negative times negative. Okay. What do you want to pick in between -2 and 5? 0. Okay, so then plug it into those parentheses again. What is 0 plus 2? Positive. What is 0 minus 5? -5, yes. A positive times a negative is? Negative. Okay. What do you want to pick bigger than 5? 6. 6 plus 2? Okay, positive 8. 6 minus 5? Positive. Positive times positive? Positive, all right. Okay, remember it equals 0 at those points. Right there and right there. And then I want the positive sections. Okay, so how do you write your final answer? What's your domain? Okay, yes. No. So the reason we've skipped those so far, if you were to graph these parabolas, like x squared minus 3x minus 10, that's a parabola that looks like this. Do you see how it's above the x-axis here and here? Those are the positive parts. So let's say your parabola looked like this. This is actually the positive part. It's going to end up being in the middle. And what if you had a graph that did something like that? You know, you'd test, you'd have a negative, and then a positive section. It has to do with the end behavior stuff. Yeah, and like multiplicity of your zeros. Yep, all of that stuff goes back. Okay, let's start the next one together. I'll have you guys do the number line part on your own, but I want to make sure we factor correctly.
We always do the 2 that are on.
That's just what Rachel was asking. So the reason we end up with the 2 that are on the end is because you see how this is a parabola that's going on. The 2 ends are what's above the x-axis. That is the positive part. If you had a parabola, let's say this was a negative in front, it would be that middle section here. Okay. All right, so let's look at 11. So we start with our 25 minus x squared has to be greater than or equal to 0. And guys, the only trick on this one, be careful with your factoring. What does this factor into? Okay, 5 minus x and 5 plus x. That is different than x minus 5 and x plus 5, okay? All right, and what are the 2 points on your number line? Negative 5 and 5? Okay. What makes this 0? Negative 5. What makes this 0? 5. Okay. That's what we're doing. That's it. All right. So you guys try to create your number line and write your domain. See how you do. How are we doing with this one, guys? Do you have it, or do you need a minute still? Which section did you guys get as the positive part? Ends, or the middle, or something else? Middle is correct, yes. So if you plug in like negative 6, you'd have positive times negative, which is negative 0. Positive, positive, positive. Positive, negative. These are included. So your answer should have been bracket negative 5, 5, bracket. How many got that right? Okay. Questions on 11? All right. You guys want to try 12? All right. Can you do it? Do you need to stand up and like do some jumping jacks and wake up for a minute? You guys seem like you're slowly dying on me a little bit here. So. Yeah, I know. We just don't have time today. You can take one right now. What do you need to do? A little bit. It's just sort of putting the roots and the fractions together. So, try 12. We already did some fractions. Do you remember? Okay. We're going to put both together. We're going to do like the... Not in number 12, but he said, is there more? Yes, I'm actually checking how much more. A little bit more. We'll be okay. We'll make it good. Stack.
So,
Yes, that will work. You could also take a 3 out, but you don't. It's not the end of the world.
oh, right.
It's easier if you take the 3 out. So try that. But then, yeah.
Wait, you know, take out the x squared, just should just.
No, take out the 3 and the x squared. He only took out the x squared.
Wait, we took out 3x squared. Is that
Yes, that is good.
Wait, but then it could be. Is that equal to 0?
So think about what are the 2 things that would be on your number line. What are the 2 places it would equal 0?
And I don't know.
What would make x squared 0 if x were... Don't overthink this. Don't overthink this. What number times itself is 0? Yes. So that's the
But
other
what
point.
about the 3? Nothing happens with that.
So those are the 2 points on your number line, 0
Oh,
and
the
3.
I got the 3 from the x times.
Oh, yeah.
Oh, that 3?
Oh, there's
That's
3,
right.
So it doesn't matter.
Right.
Okay.
And really the 3 connected to the x squared doesn't do anything.
What if that was a 4?
Connected to the x squared?
Yes.
Wouldn't matter. Because 4 times 0 is still 0. You figure out what would make each factor 0. That's what goes on your number.
Wait, now do I have to use negative?
Are we dying, guys?
Yes.
Ah. All right, let's start. All right, step 1, yes? Everyone's okay with that? Okay, factoring. I would take out a 3x squared. Three x squared. I said you needed to also take out 3.
Why do you do this? That's not nice breaking.
Okay. So guys, once it's factored, that's when you figure out what goes on your number line. All right, so when you're looking for your number line, what are the 2 things that would make this 0? This is easy. 3. This is even easier, but you guys always overthink it. 0. 0. Yes. 0 squared is 0. Woo. Okay. So we have a 0 and we have a 3. Yes? Did everyone get here?
Make that sooner.
Like, set your factors equal to 0? Yes. Yep. Okay. Now we plug in. What do you want to use left of 0? -1. Okay, what's -1 squared? Okay, does times 3 even really matter? Okay. It's clearly going to be positive. What is -1 minus 3? Negative, right? So overall, negative. What do you want to use in between 0 and 3? 1, lovely. What's 1 squared? Okay, so a positive. What about 1 minus 3? Negative. So overall, that is... Oh, it didn't alternate like all the others did. Huh? All right, what do you want to use past 3? 4. Okay, 4 squared. Positive. 4 minus 3. So overall. Okay. Are we okay with the number line? The answer for this one is a little trickier. We want greater than or equal to 0. Remember, it equals 0 at these points. And then the greater than is over here. Okay? So you need the 0 as well. So your final answer, the way you can say just the 0 by itself, you can put it in its own little set of squiggly brackets, and then from 3 to infinity. That is your domain. It's very easy to forget that 0. Don't do it. Try to remember. Depends on my mood. All right, guys, are we okay with the number line? It's very systematic. It's a process to go through. Just try not to forget your steps, okay? It's something if you practice, it's really not that bad. Ready for more? Maybe? Let's see. What do I want to do? We don't need that. Alright, we are going to do these. But then this is it. This is our last two. Am I on 13? Is that what number I'm on?
Yeah.
So again, guys, we are stating the domain. So go ahead and just jot down 13 and 14. Last two. No, we can do this.
But this is it. Like,
What? Are we ready? I'm gonna do them with you, okay?
Then I'm gonna do. Oh, wait,
All right, guys. So let's look at 13. All right.
Yeah.
Do you guys think of that now? Yeah.
Yeah.
I'm happy to help. The no pants thing for dividing by 0.
What are we?
I like our way also.
Side note. So that's 0. That's okay. A guy can take his shirt off at the beach and it's fine. That is not okay. Okay? Now you'll remember. All right. What? I hope you just remember that you should keep your pants. There you go. All right. 13. Okay. Do you guys see how on 13 I have, guys, I have both. I have the square root and I have the fraction. Yes? Okay. So what do I know about a fraction? Which part of the fraction do I care about? Okay. So this x plus 2, is it doing anything? No, we don't care about it at all. Okay. We care about the denominator. And normally when you had a radical, you would say what's under there was greater than or equal to 0. It's in the denominator, though. Do I want it to equal 0? No. So that's the only thing that changes. We make that just greater than 0. And then you solve it just like you did before. Am I going to need a number line for this one? No. Okay. Just easy solving. Add your 1, divide by your 3. So it's just parenthesis 1/3 to infinity. Easy? Not bad, right? Easier than the number line ones, right? Right, because it's in the denominator. Because if it equaled 0, you would be dividing by 0, and clearly that is not okay. Clearly. It's a good rule. All right, 14. This is like as tricky as they get because you've got the radical in the numerator and then you also have the denominator to deal with. So you've got two pieces to deal with. So I'm going to start with the denominator. So x squared minus 4. I don't want that to equal 0, right? That's where we would have problems. So you can factor it.
So the denominator on 13, that one had to be greater than 0 because it was under a radical.
Yes.
One can't, because it's not.
So neither of them can equal 0.
Yeah.
The radical, we changed it to just greater than 0 instead of greater than or equal to.
Yeah.
Because I don't want negatives, but now I also don't want a 0 under there.
Okay.
This, I don't care, it can be negative, that's fine, it's just the denominator. But it definitely cannot equal 0.
Okay.
Not okay to have 0 there. No. No. It's not. Alright guys, so what are the two things that x cannot equal here? What? Yeah, 2 and negative 2. Okay? Do we get that piece? Before you write your domain, you have to go think about the numerator too. So I've got a square root up here, right? So I take what's under the square root, and I say that has to be greater than or equal to 0. Do you guys understand why it's back to being equal to 0 too? Okay, numerator, that's okay. All right, so if I solve that, I've got x is greater than or equal to -4. I'm going to make a picture out of this. You're not doing a number line test. I'm just drawing a number line so that I can get my 2 answers on there so that I can visualize it better. So x is greater than or equal to -4. There's -4. It equals it, and then everything greater than. That would be over here, right? So that's one piece. But then from up above, what else can x not equal? Okay, so that means I've got like an open dot at -2 and another open dot at 2. So if you are actually writing this in interval notation, it's got, do you guys see how it's got like 3 pieces? You're going to have 3 pieces to your answer. It's going to be bracket -4 to -2 parentheses, -2 to 2 parentheses, and then 2 to infinity. Okay? I don't want you to mess it up because you have to make sure you include this and this. So I recommend making the picture with the number line just so you get the right answers for your actual domain. Okay?
Now, why is the first one easy?
Sure. Any questions, guys? Take your time, like think through the steps. Always ask yourself immediately, is there a fraction or an even root? If there's none of that, just write all real numbers, okay? Questions on anything? All right, guys. You have time to work on your homework. Let's not do the entire thing.
Yes.
Oh my god, is that all of our homework?
Let's do odds again.
23?
What? Why are we whining about odds? I'm so confused. Well, you are welcome to do all of them.